Hello, I'm Richard Hooper and this is SatTV Week. Now I'm pleased to be joined by Terry Bleakley of Intelsat. Terry, it's a long time since we've spoken, but tell me a little bit about the global trends Intelsat are seeing.
Yeah, hi Richard, good to see you again. So let me just talk a little bit about what Intelsat's doing with its high throughput strategy globally and how that sort of weaves into the trends we're seeing. So Intelsat has sort of been innovating with its high throughput satellite technology. We've been talking about EPIC for a number of years, our high throughput marketing name for our satellite. We launched our first EPIC satellite in late January this year, IS-29E, and it's the first, it's the most expansive digital payload in the market. It's backward compatible with our fleet, and it's performing above spec. The satellite was made by Boeing, and we're seeing about 2.5 times efficiency over a normal KU band beam on the satellite. We've got 6 more in the factory with Boeing, which is 7 EPIC fleet being launched by the close of 2018, so part of our global high throughput infrastructure. Those 7 satellites will double our fleet capacity. So people ask us, where is the demand coming from? Where do we see the demand for high throughput? And there's 6 verticals that we lead in today, and in those 6 verticals we see incremental growth of about $3.1 billion of new revenue. Those 6 verticals are in enterprise networks, so looking after global customers, United Nations, embassies, etc. The second is cellular backhaul, and we see a great role for high throughput in cellular backhaul as people move from 4G to 5G and densification of cells. We see Internet of Things as being a growth area. We see aeronautical, we see maritime, and we see government. So with those 6 sectors which we lead in, we see about $3.1 billion of incremental revenue. So we're sort of innovating in the sky with our high throughput satellites, but we believe it's not just about creating more efficient and more throughput in the satellites. It's about innovating on the ground and the whole ecosystem. So we need to make satellite more accessible, we need to make it smaller, we need to make the antennas cheaper, thinner, and just a part of the node on the network. And to that end, Intelsat's been investing in a number of antenna manufacturers. Kymeta is one, a company majority owned by Bill Gates, and they're making a passive array flat antenna in 2 segments for us, which is the connected car and the maritime segment. And why that's really exciting for us is we're making markets that weren't accessible to satellite. So let me talk for a little bit about connected car and what's driving that. So we announced in the Detroit Motor Show this year that we'd be working with Toyota and Kymeta on the connected car project. And what's driving that? Well, if you look at a car today, a car is a very complex piece of equipment, has more than 100 million lines of code. Now if you compare that to a 787 aircraft, that has between 6 to 8 million lines of code. So the car we drive to work is a lot more complex than the aircraft we fly. And if you look at statistics over the last year to 18 months, major car manufacturers are seeing 60 to 75% of issues with cars are not mechanical, they're software related. Now Toyota, every time a car goes back to a service center, they pay, in the US, they pay that service center $80. And if it's for a software upgrade, that's a lot of money to pay for a software upgrade. So they're looking at ways of getting more efficient at upgrading softwares to car, and it's called sort of over the air. And they've looked at global mobile phone networks, and they've looked at wireless technologies, and they've looked at satellite. And to them, satellite makes a lot of sense. Satellite's ubiquitous in nature, it's great at broadcast, and what's happening with software upgrades for cars, it's one file going to millions of cars. So it's like DTH and satellite. So that one file going to 10 million cars on a satellite network is the most efficient way to distribute it and the most cost-effective way to distribute it. So they've looked at a global mobile phone network, and it's just a lot more complex. Security is a big concern. If you imagine upgrading the brake system with software and that file gets corrupted, real concern for the car manufacturer. So there's a lot more security around satellite than a mobile phone network. When Toyota did an analysis, they saw many hundreds of millions of points of entry in a global network stitched together for being able to access and potentially corrupt a file. With satellite, they saw only a few points of entry, which is the uplink points in the global network. So security and cost were big drivers for Toyota to look at satellite as a way of providing over-the-air upgrades. Now, why it couldn't be done in the past was a parabolic antenna on a car doesn't make sense. So with what Kymeta's doing with a 15.5 centimetre antenna, flat, that has electronic beamforming which follows satellite, makes a lot of sense. So one application that didn't exist in the past, where we see satellite playing a role in the future due to what's happening with innovation on the ground and not just in the sky. And that sort of leads on to something else that we're doing which is quite innovative, which is our investment in OneWeb. So OneWeb is a LEO constellation which will be progressively launched from 2019, and we've invested in OneWeb. It will be using KU band spectrum, the same as what we're using on Epic. And if you're in a car going down an urban canyon, say you're in Manhattan, you've got those two tall buildings either side, it's very hard to look at a satellite. Now with the OneWeb constellation, there's over 700 satellites. There are 18-degree planes around the Earth, so you've always got a very good look angle. So there's connectivity in those urban canyons that were difficult to connect before with satellites. So we see innovation with constellations, with high throughput, with antenna, creating a solution that's going to potentially change how we service our cars in the future. So one area that's really interesting. Another one is in aviation. So we've been working with Panasonic and Avionics and GoGo, two big providers of Wi-Fi to planes. They've both taken KU band traditional beams from us and high throughput beams on both our first two satellites, IS-29E and IS-33E, which is launched Q3 2016 for Asia. And that will provide true broadband access to aircraft. Not what we're getting today, that very limited access. This is true broadband access to aircraft. But I believe another driver of that is not the welfare of the passenger or looking after the passenger, but it's actually what's happening with engine manufacturers for aircraft. So GE and Rolls-Royce now have very fine sensors on engines they're creating for aircraft, and they have enough information to download 1 terabit of data a day. So for them to have aircraft that have true broadband access, they're going to get a lot more information as what's happening to that engine as it's in flight. They can have engineers ready on ground to service when an aircraft lands. They can monitor progress of aircraft as they're going. And it's going to be a fascinating way that this is going to be used for aircraft going forward. Again, due to innovation with high throughput and with antenna technology that is being used on aircraft.
The innovation that you're talking about and the things with Kymeta
Yep.
and the HTS,
Yep.
are these the game changers that companies like yourself are looking for?
Yeah, look, I think it's not just about one, it's about everything coming together. So it's about making the antenna more accessible, smaller, cheaper. It's about using more aggressive modulation techniques, and with the higher throughput satellites and them being a lot hotter, you can push the modulation techniques that were used before, and the cost per bit comes down. And the size is very important, and the complexity, making it a lot less complexity, is very important to open up addressable markets. So if we do it right, if the industry does it right, if there's new constellations, there's other high throughput satellites coming, there's other antenna manufacturers that are looking at other ways of providing easier access. But if we do it right, I believe satellite will take more of the telecom slice than they take at the moment. Will no longer be that last 3% or 2%. We will become a core part of the network going forward.